Okay, the next data structure I want to look at is the double linked list. It's very similar to the linked list, or sometimes referred to as the single linked list, in that we have nodes connected to other nodes. In this case, our node has three parts to it, as I talked very briefly when I talked about the nodes. It has the data element, of course, and then it has two reference or pointer parts to it, and one points to the previous node, one points to the next node. The sort of actions that we'll have in a double linked list are exactly the same. We can insert, we can delete, we can search. The advantage of having two references there, the previous and the next, is as you search around, if you go past something, it's very easy to come back. Or if you've already got something partway through a list and you're trying to go backwards, normally you'd have to start right at the beginning again. With this, it allows you to go backwards as well. So if you think about the other data structures we talked about, when I talked about the stack and the queue, I said normally they are implemented using arrays. But we could implement them using linked lists, and that would mean that the stack and the queue structure is now no longer constrained by the size of the array. Remember, an array cannot change size once it's created. So what we can do, if you think about the queue, is we want to push elements at the end of the queue and take them off at the front of the queue. And really, a double linked list is ideal for that because we've got access to both ends of the linked list. And then we don't really care about how big it is. So what we need is up here, we've got now two, not just the start, we've got the start and the end, or really there's many different names we could give that. These are single references. One of them goes to the very first node and the other one goes to the very last node. And then as I've got them here, we can see I can go from the first node, its next will take me to the second node. Its next will take me to the third node. Its next is null, so that tells me that's how long the list is. I'm now at the last node. If I go to the previous, that will take me to the second node. If I use the second node's previous, that will take me to the first node, and I know that's the first node because it's null. The insert and delete, the concepts behind them are similar to the linked list. The only thing now is you've got two pointers to take care of. So let's just look at how we might try to insert a node. So I'm going to take a node, I'm going to try and insert it between the second and third nodes. So what is it that I need to do? I will need to have the previous on the last node to come to there, its previous to point to the second node. The second node's next needs to point to here, and its next needs to point to there. So those are the changes I will need to do. So now what we need to do is think, well, what order do I need to do those in? So I've got my new node. It's usually a good idea to say, well, before I change any of the existing nodes, let me set up the new node first. So if I've got a node that points here, for example, and I've got my new node, and it said this is the location I want to insert it in. So this is, I'm going to call this node. Okay, so node and dot next. That points to the last node at the moment. I want to assign that into my new node. So what I would do is I would say new node. I haven't given myself space here. let me just, new node dot previous equals node. So that previous one will set this up here, and it's going to point to there. New node dot next equals my node dot next. My node dot next points to the third one, so this one is now going to be set up correctly. Now that those are set up, it's quite easy for me to do the other ones. New node dot next points to the last one, so I can get this in a number of different ways. New node dot next dot previous equals new node. So new node dot next, that's the last node, dot previous, that's this one here, is now going to point to my new node. And node dot next, I now want that to point to my new node. Okay, that's one way in which it could be done. I'll just point out that this line here could have been done as node dot next dot previous equals new node. This would be node dot next dot previous, and then I'm changing that value. I'm changing that value to be new node, so it points back to the new node. So a little bit more work. We've got, whenever we do an insert, we've got 4 nodes to worry about. When we do a delete, I've got to make sure that the next of the previous one, say I want to delete this one, then I need this one here to point to the next one. And the next one, if it was this one here, its previous has got to go back to there. So there's 2 nodes you need to play around with for a delete. The search doesn't really change, other than we can now search forwards and we can search backwards. And if you know something about your data, maybe your data is in some sort of numerical order or alphabetical order, and you're looking something towards the end, it might be more advantageous to search from the end of the list rather than from the beginning.